Alright, Algebra 2. Sorry I couldn't be here today. Yeah, I had a dentist appointment. So, wanted to go over Algebra 2's 2-2, Characteristics of Relations and Functions. It's in your packet. And before we started, I wanted to give a shout out to those people that finished not only their coordinate plane activity from Friday, but they checked their work on the calculator, and that would be Amanda and Jordan, and maybe some others, but those are the two that I remember. And then the people that actually got through with their vocab, as well as the coordinate plane activity, and that was Kevin and Brianna and Logan and Mason and maybe a few others, but those are the ones that stick out in my mind. So, let's get started on characteristics of relations and functions. Be sure to use the pause button, tell the sub when you want to stop. If you're going together on this, or if you're doing it individually, stop when you need to. So, remembering the difference between relations and functions. Remember, relations and functions can be expressed with coordinates, and that would be x, comma, y, or x, comma, f of x, close, close. We can show relations and functions with a graph on the coordinate plane. So we would have sometimes all four quadrants, not always. We could show relations and functions with a table, in and out table, or x and y list. Okay. Now the big defining thing between relations and functions, this is the difference. They both can have coordinates, they both can be graphed, they both can have a table, but only one of them can have repeating x values. Only one of them can pass the vertical line test. And really, only one of them can be patterned with a rule. Later on, we'll learn some exceptions to this. So function notation is just a fancy way to say y. I worked with some people on their definitions last Friday. F of x is the same as saying y. So we would write the coordinate instead of x comma y. It's written x comma f of x. Or you might give it a different name like g of x or h of x. Sometimes I like to call it the Fred function, the George function, or the Hilda function. And if they have special names, then sometimes we don't get them as mixed up, especially when it comes to a verbal word problem. But we're not in verbal word problems today. We're just basically reviewing calculator skills on the input and output using function notation. So on number 3, if you need help with the calculator, here's the key sequence you would put in to find the f of 4 and the f of negative 1. You would do 2 parentheses, 4 parentheses, plus 3, enter. Well, why not just say 2 times 4, Miss Murray? Well, the reason why was because the calculator only knows as much PEMDAS as you do. So you might get the answer correct one time, saying the 2 times 4 plus 3, and then another time you might not get the correct answer because of the way the problem is set up, and it does not read PEMDAS. So be careful with your parentheses. You could also put this little function in y equals, and when you do that you would press second graph and scroll through to find the values for 4 and for negative 1. So fill in the blanks and answer the questions as best you can about the ordered pair that fits with this function. So I'm trying to keep this short and sweet to just give you some hints because I don't know who my sub is and how much they know about the calculator or how much they know about math. So I didn't want to leave y'all hanging as much as you wanted a free day, I know. So number 4, be sure and plot the points labeling the axes that are given. And your hints I'm going to give you for A. It says identify the domain. So you would put D colon, and looking at those points, you would list all the x values. Make sure there's a comma between each one. On B, identifying the range, you would put R colon and list all the y values out the same way with commas in between. On C, you would answer the question, well, does this, looking at the graph or looking at the coordinates, the graph, what you would check, does it pass the vertical line test? Looking at the coordinates, you would want to see if any of the x values repeat. And on D, it asks if it's continuous or discrete. I know I wanted to wait on that vocab word until today, so I'm going to kind of give you some hints on it before we do it this afternoon. Basically, continuous or discrete. I want you to answer the question, can the points be connected because there's a pattern? And if the points can be connected, then we would call that continuous. And if it's continuous, it is connected together. We could find values between each point. Looking at this set of coordinates, I don't believe there's any way to connect them. So, answer the question, continuous or discrete, and explain your reason. So, my helpful hints for number 5, looking at the one on the left, the zigzag one with the open point and 3 closed points, we first want to identify the domain. Well, I'm helping you out by giving you D, colon, and the domain is all the x values left to right. So we would say that the domain would be anything from -2 and +4. Now, it does not touch the 2, that's what the open circle means, but it does touch the 4, so we have to say less than or equal to. So make sure you keep that note that there's the equal to on that one. Going on to the range, identifying the range, you look up and down. Okay, so look at your minimum value on the range. Well, this dips down to -4. And it goes as high as +3. Does it touch the -4? Why, certainly it does. So I get to use the less than or equal to. And does it touch the +3? Again, it does. So it's less than or equal to. So the range is anything in between those up and down values. Now we want to find out if the relation is a function. Does it pass the vertical line test? Does it touch the function in more than one place at a time? Does it have repeating x values? The next question, is it continuous or discrete? Well, I'm going to remind you what that would mean before you do your definitions this afternoon. So, is it continuous or discrete? Is the data connected? Are there values between the points? That would mean it's what? Continuous. So, it doesn't say you have to explain, but you just have to answer the question. Now, we move down to the 2 questions about intervals. On what intervals is it increasing? Well, increasing intervals are written on the x, about what's going on the x-axis from left to right. And there's 2 increasing intervals from left to right. And you would just have to write both of those. I'm not going to write them here because I'm going to run out of room. But I want you to be sure and look at those because I want to help you with it. The first one is increasing from -2 to 0. -2 to 0. You can write that a couple of different ways. I'm going to let you write it either with words or if you want to try interval notation, you can, but I'm not requiring it right now. I don't expect mastery on that. The second interval, look carefully, it's over there in the 4th quadrant. But that doesn't really matter. We really just want to look at the x values that it's increasing on. So the x values that it's increasing on is, look carefully, and your sub has the answer if you really need a hint to check it. Now the last question, it says on what intervals is this function decreasing? Well, it's only decreasing in one place. So look at the x-axis values from left to right. The x-axis values from left to right where it's going down. That would be from 0 to, and you figure that one out. Now I expect you to do the second one on your own. It can be kind of tricky because it's continuous in that first quadrant. So be very careful about that one. Now we've got to be careful on number 6. My helpful hints for number 6 is to give you the key sequence for the calculator. You would press y equals 2, and then you would look for the math key. And I'm having to do this from memory. I think you'll come up with a selection there. Not frac, that's the first one. You'd go down to where it says abs for absolute value. They give you a grouping of parentheses, but they tell you it's absolute value. So I think it looks like abs with the open parentheses. Then you would put in x minus, not negative, and then 1. And then you need to close the absolute value symbol. So fill in your table of values, sketch the graph, and answer the questions. On the second function on the right, we have y equals 2 square root x plus 1. So I'm going to write that one down because it looks like this. Y equals 2 square root x plus 1. But when you put it in the calculator, it may look a little different. In the calculator, you'll press y equals, make sure you've cleared out your first function, 2, and then you have to hit second x squared. And when you do that, you end up seeing 2, and I believe it goes square root with a parentheses kind of, and then you're going to have to hit the X button plus and then 1, and then you'll need to close your parentheses. So on your calculator, it will have the grouping of parentheses so that the calculator will know that the square root is taken of that whole group. Fill in your table, sketch the graph, answer the questions. On the parent function questions, be sure and look back at the parent function cut and glue that we did last week. Now our vocab for tomorrow is about continuous and discrete. So we kind of have talked about continuous and discrete today. Go ahead and write the definitions on your packet in the vocab section. If you want to draw a picture of what continuous and discrete looks like, that's fine. But those words are what I expect for tomorrow. Because when we go in tomorrow, we're going to discuss a little bit more about continuous and discrete data. See you then.